in the Flesh fans. Welcome to another magnetic force on moving charges problem. A proton moves at a speed of 1.2 times 10 to the 3 meters per second in a direction perpendicular to a magnetic field with a magnitude of 0.95 Tesla. Part A. Calculate the magnitude of the magnetic force on the proton. And B. What would the magnitude of the magnetic force be if the particle were an electron? So the nice thing is we don't have to use right-hand rule here because we're only asked for the magnitude of the magnetic force. And so really we just have to use the following formula. Magnetic force FB equals QVB. Okay, so charge, speed, and magnetic field. Now, with these types of problems, just like in projectile motion problems, you're not told G is equal to 9.8. Maybe in the first or second question, then afterwards you just have to assume you know it. For these questions, if it's a proton or an electron, the charge is not given. The mass is not given. Those are things that you are expected to either have memorized or you were able to look it up. So the charge of a proton is the electrical constant E, 1.602 times 10 to the minus 19 coulombs. The V is given to us in the problem, 1.2 times 10 to the 3 meters per second, and the magnetic field strength is 0.95 Tesla. So multiply those through, and you end up with 1.83 times 10 to the minus 16 newtons. Don't forget the unit. It's a force, so the force is measured in newtons, and we're asked for magnitude, so no vector symbol on top of the FB. Okay, so there's the answer for part A. Now part B asks, well, what happens to the magnitude of this force if the particle is an electron? So looking at the formula, the only thing that's going to change is Q. Well, a proton and electron both have the same charge, the charge of an elementary charge, E, 1.602 times 10 to the minus 19 coulombs. The only difference is an electron has a negative charge, and therefore it's going to move in a different direction because it has the opposite charge to a proton. But we're only asked about magnitude here, and the magnitude is going to stay the same, okay? Because the particle has the same magnitude of charge. The direction is different, that it's going to move, but we don't care about that in this problem. And that's actually it for this problem, guys. I hope you enjoyed it. Again, as usual, be sure to smash that like button and subscribe to Physics in the Flesh if you haven't done so already. Stay tuned next time for video 175, Magnetic Force on Moving Charges 4.